Guys, I'm going to try something different this week. We have one more surface area topic to learn about, and that is spheres and hemispheres. So what we're going to do, we're going to start with spheres first and then talk about hemispheres. We're going to do this activity in class, but alas, that's not happening. So if you want, you can just watch me do it, or you can follow along. All you need is an orange. I like using the mandarin oranges because they're easy to peel, but a normal orange would work too. And a piece of paper and something to write with. The peel of the orange demonstrates surface area really well. I will say right now that the surface area is related to the great circle, which if you remember that is the biggest circle inside of a sphere that you can make from it. So I am going to start by tracing the great circle on my paper just a few different times. I will tilt this down so you can see what I am doing. So I'm going to do it probably maybe 5 times, see how many times I can get it to fit on there, is just trace the outline of the orange. That was really bad, but you get the gist. Feel free if you want to fast forward through this part and pretend like I'm a better artist than it's showing you. Go for it. So some of these I got a little off. That should be a little bit skinnier than it is. But okay, so I have my, wow, that's beautiful. My 4 different circles. This sphere, I know it's not a perfect sphere, but we are using our imagination. We're going to assume it has a radius of r, and so if each of these is a great circle of the sphere, then it also has a radius of r. Which, in that case, what is the area of one of these circles? That's right. Maybe, I hope. Pi r squared is the area of the circle, and in theory the area of all of these circles if I drew them a little bit better. So what I'm going to do is I am going to peel my orange and see how many of these circles the peel will fill up. So my next question is, what's your guess? How many of these circles do you think this peel will fill? Okay. Now I'm gonna just get started here. So if you are doing this at home, I would recommend not doing what I'm doing. I've never actually peeled one quite this well before. But when you have big pieces like this, they don't lie flat very easily. So our pieces actually need to be pretty small. I don't want them curving up on the edges. Once again, feel free to speed this up or skip on. And remember, this is not perfect for a few reasons. One, because a sphere or a orange or a clementine, especially the clementines because they're a little bit flatter, but they're far from being perfect spheres. They are flatter, a little more squished than a sphere would be. Also, there was some definite human error on my part in drawing these circles, so that will make our answers off by a little bit as well. Let's see. And then if you are doing this, once you've got yours in small enough pieces, we're going to start trying to fill up the circles. And remember, we don't want any of these pieces to be rounded or like curved up in any way, because that will throw off our calculations. So now that we've ripped up the peel a little bit, I don't know if you have any different guesses from what you initially had of how many circles it would fill up, but let's get started. I'm going to get some big pieces first, and then I'll go in and fill in some gaps later. And you also don't want any of your pieces to be overlapping, because that will mess up our stuff as well. And you can do it either side. I probably should have done the shiny, pretty side faced up, but you can do it anyway. Let's see. Some of these pieces are a little big and curved, so I'm breaking them into smaller pieces as we go. This was one of my favorite activities to do in class. One, because I think it's a fun visual, but two, it makes my classroom smell really good when y'all are doing this all day. So I'm a little sad that we're not getting to. Now where I'm stopping right now is probably going to give away the ending a little bit, because I'm going to come use some of these pieces instead of moving to this fifth circle. I'm going to fill in some of these gaps down here. And my husband is getting to learn some geometry today as well. Unless, did you already know the surface area of a sphere?
The formula or?
Either. Anything.
I remember you telling me about this and I was super impressed by it.
Okay, so I guess I taught him in previous years, but he doesn't remember, so he's going to get to learn again today.
Yeah.
So right now I'm just trying to fill in these gaps. Squishing this together a little bit. Remember, my circles are not perfect, but that piece looks like it will fit pretty well right there. Getting closer. Now these pieces I just need to get really small to get into these gaps that we have. Now I said try not to overlap them, but once again, what we are doing right here is not a perfect science. If you're still watching this, I'm impressed because it's taking a while to get it just right. Let's see if we can fill in some pieces here. And as you can probably start to tell, in theory, if this were perfect circles and a perfect sphere and a perfect world, it would fill up exactly 4 of the circles. So I'm not going to go through and do all of this perfectly, but like this piece that I have left, if I broke it up into tiny pieces, I could get it to fit into these little cracks in here. So That's been so far my 10-minute demonstration of peeling an orange. But that shows us that the surface area of a sphere is actually equal to, we said each of these represented an area of pi r squared, and it fills up 4 of them. So the surface area of a sphere is actually 4 pi r squared. This little piece is bothering me, so I am going to try and fit it back in, and I'll show you at the end that for the most part it fits 4 circles. But for right now, let's see, we have surface area equals 4 pi r squared. This is the surface area of a sphere. Now, hemispheres are a little bit trickier than you might think. What do you think would be the surface area of a hemisphere compared to that of a sphere? So, if we were looking at just this part of the sphere, that would be 2 pi r squared. But spheres, or hemispheres, now have a base that a sphere did not have initially. So this circle right here is another pi r squared. So the surface area of a sphere, or a hemisphere, rather, is 3 pi r squared. So, sphere, hemisphere, is 3 pi r squared. And once again, this is area, so whatever our units are, they will be squared and not cubed, even though we're looking at a 3D figure. So, for our assignments this week, these are the formulas you'll need to know. Surface area of a sphere is 4 pi r squared, and hemisphere is 3 pi r squared. We did some volume stuff last week, and so volume of a sphere, if you remember, is 4/3 pi r cubed. Volume of a hemisphere we didn't actually talk about, but it is pretty straightforward. It is just volume of a sphere divided by 2. So 4/3 pi r cubed divided by 2, I think, is the easiest way to remember that. So, I lied, I didn't finish my orange just yet, but I'm going to try and fit it in there and show y'all my final product. And it's really hard to get these little gaps that are left, but there you go. I have no pieces of it left, and you can see it fits 4 of those circles almost perfectly.